So here's a video setting up the basic acoustics section of this phonetics course. Now, first, I want to identify acoustics. Sort of, it lives in that middle step of the phonetic sequence. Um, when you're dealing with vocalized speech, there is speech production. We've dealt with that. We've looked at the anatomy and physiology, production of different speech sounds. There's the transmission. That's the sound waves that we're going to be looking at here. And then at the other end is the perception, hearing the sounds and recognizing them. We'll deal with them later in the course. So in this module, we're going to look at the nature of sound waves and talk a bit about that in this video. And then we'll move on to looking at their physical properties and thinking about how we measure them and do some reasoning and calculation about them. All right, so sound waves are basically changes in pressure. They can be changes in pressure in any physical substance that will be transmitted through it, but as we experience them, as we're mostly interested in them for speech, they're changes in air pressure. There are other ways that air pressure can change. Atmospheric phenomena, weather, involves changes of air pressure, but this is slow. It happens over hours or days. It's also large fluctuations in pressure. Hectopascals is the scale that we're given in the textbook. That's hundreds of pascals, pascal being a unit of pressure. And it also happens over wide distances. That change in pressure will be experienced over kilometers of distance. Sound, on the other hand, is quick. Sound, at least as we understand it, normally happens in the span of milliseconds, these fluctuations in pressure. Also, these fluctuations are small. They're micropascals, millionths of a pascal at the low end, of what we can hear. And also, these are fluctuations that happen over small, short distances, right? Centimeters or meters. The wavelengths of these sounds are centimeters to meters, and we hear over sort of just a few meters distance normally. Another thing, and I'm going to point to some other animations that illustrate this nicely. The nature of a sound wave it's important to keep in mind. When we think of waves, we often think about the up and down motion, for example, in water waves. But a sound wave is a pressure wave, also known as a longitudinal wave. And that's because each individual particle in this wave, if I have, for example, a sound wave moving from my mouth to the microphone of this computer, the sound wave is going in that direction. Each particle is actually moving along the line of transmission, right? It's not that a particle is starting here and ending there. They're rocking back and forth, just like the particles in a transverse wave, or the elements in a transverse wave move up and down. They don't end up traveling anywhere, the individual particles. It's the energy of the wave that travels. So with longitudinal wave, you have changes in pressure. The particles here push against the particles next to them. Those particles go in motion, and these particles, they all sort of oscillate back and forth. So that's a longitudinal wave. We are going to see when we measure them how we take this longitudinal wave and depict it as something that looks a bit like that up and down wave. But we'll be very careful about how we're doing that, why we're doing that, why it looks like that. Okay. And I think the last thing that I want to mention in this video is just that the sound has a speed. That speed is different in different substances, in different atmospheric properties, but it is a speed, and that's going to work into some of the other properties that we look at as well. As phoneticians, we're not generally measuring the speed of sound, but there are some situations where the speed of sound is crucial to knowing other properties or predicting other properties. And in a typical atmospheric condition, transmission through air, the speed of sound is somewhere around 340 meters per second. Maybe a bit more. Okay, so that's a good setup, and we'll get deep into looking at sound waves and their properties in the upcoming videos.